Okay, guys, here we are back with 15.3, using measures of center. Two types of measures of center that we're going to be talking about are going to be mean and median. We alluded to those back in section 1. So first example here from a key concept perspective, you can compare the data values um, and make a comparison of those using either mean and or median. You can see the example here, class M has a mean of 4 500ths, whereas class R has a mean of 5 1/10. Recall each of those data points represents that particular number. And so we would compare those and say, hey, the average or the mean of class R is greater than the class M would be. Okay, let's move on to part 1 here. We got 3 different parts, so you can basically break it down to say, hey, 4 or 5 questions are going to come from this particular section. We have this questionnaire.
I know a call. Pretty bird. Cockapoo. From New Zealand. Doesn't talk, that one. Only want a cracker?
All right, so we take a look at that situation, okay? What you see here is going to be known as a box and whisker plot. And you can see that we're going to make an inference or an educated guess based on what we see. And we're talking on this first example about the medians, all right? So the nice thing about a box and whisker plot, it's pretty easy to read. The median is this line right here on the McCall, and on the Cockapoo, the median is this. So this line represents the median or the middle number. So you can see the middle number on the McCall is about 42 inches in terms of the wingspan, whereas in regards to the Cockapoo, it's about, I'm going to go out and say about 33. Okay, so obviously what we would say is that the wingspan, based on what we're seeing here with our data, the wingspan of the McCall is greater than the wingspan of the Cockapoo. All right, and so that's really all we're looking for on this particular situation. I don't see any point in running through that. Here's another one that's tying with Mrs. Rockwood and Mrs. Bourne's class potentially in regards to AR book published for testing 2 versions of the book. A random sample of people given 30 minutes to read those. What's the median of each sample, and then make an inference based upon those numbers. So if we take a look at this, version A looks like the median is 25. Version B, the median is 23. Okay, so we basically took care of the first part. What's the median of each sample? Now we're going to make an inference about this, and so there's a number of different things that we could potentially say. Version A, obviously the person who read version A, since they read 25 pages as opposed to 23 in version B, perhaps the print is larger, you could say. You could argue that maybe there's pictures in version A and not in version B. You could potentially make the argument that the people who took version A were faster readers than the people in version B. So there's a lot of different things that potentially you could come out of this with. And their suggestion here was that the inference that they made is that, as we said, the median of A is greater than B, and so therefore A is an easier read than B would be. Okay? All right, moving on to part 2. And on part 2, as you take a look at what we got going on here, calculator, by the way, might be needed here in a short period of time. Biology student studying 2 species of parrots, mean weight. All right, so this is where you're going to need a calculator for sure. You have to find the mean weight. And so, in essence, if you recall, based on section 1, we're going to have to add these data points up and then divide by the number of data points that we have. So, I'm going to take 2.8 plus 3.7 plus 3.9 plus 3 plus 3.1 plus 3.4 plus 2.9 plus 3.2. Total those up, I am at 26. And then I'm going to divide it by 1, 2, 3, 4, 5, 6, 7, 8. So 26 divided by 8 gets me to 3.25 is the mean. Okay, on the Cockapoo, and again we're talking weights here. I'm going to take those weights, 3.9 plus 4.5 plus 5.3 plus 6.7 plus 7.4 plus 8.1 plus 6.4 plus 8.1 again. I get 50.4 there. I'm going to divide that 50.4 by 1, 2, 3, 4, 5, 6, 7, 8 also. And when I do so, I'm at 6 3/10. Okay? So make a comparative inference about that. Well, obviously, we would say that a Cockapoo is almost twice as heavy as a macaw would be. That would be the first thing, and I'm comparing the 6.3 to this 3.25, and so it's about twice as big, and so that's where I'm coming up with my data in terms of their weights. Okay, let's see what they had to say. Again, you can see that they also had 3.25. They also had 6 3/10, just like we did, and so therefore their inference is that the macaw is generally lighter than the Cockapoo. Right, so same thing we can say. All right, take a look at this one. And again, they're trying to make you, or they're forcing you to read a dot plot. And on this dot plot, you're pulling the numbers off the dot plot. So, for example, if I take a look at version A, I've got to say, hey, I've got 20 plus 20. And I'm pulling those from right here, obviously. And then I'm going to add 24 plus 24 plus 25 plus 25 plus 25 plus 25 plus 26 plus 26 plus 26 plus 27. Yikes. All right. So now maybe you could do it faster by saying, hey, here's 40, here's 48, here's 100, here's 26 times 3 is 78. And here's 27. So if you could do it faster that way, then, feel free to do so. My calculator, I did it wrong, evidently the first time. So I think I'm getting 333. And I've got 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 data points. So if my addition is right, 333 divided by 12 is 27.75 in terms of the number of pages. On version B, I'm going to do the same thing I just did. So 3 22s is 66, 4 23s, and again, maybe you'd be smart to go ahead and take 4 times 23 in your calculator, is 92. I have 2 24s, which is 48, and then I have a 25, a 26, and a 27. So this together is 51, and here's my 27. Okay, so I'm going to go ahead and add 92 plus 66 plus 48 plus 51 plus 27, or like I said, you could add all individual points there together. I'm at 284, I think, and again I have 3, 7, 8, 9, 10, 11, 12 data points. 284 divided by 12, I'm at 23 and change, 23.67 if I round off to the same thing as that other one. And so there's the data. What does our inference tell us? Well, it appears as though version A is easier to read. Version A's print is bigger. Those are a couple inferences that you could make due to the fact that version A, they read more pages in the allotted amount of time. All right, so let's see if their solution matches our solution. They also had, I added wrong evidently. They had 24.4 and 23.7, so my second one was right. My first one, I evidently added incorrectly, and so their inference based upon that is we read more or faster or more pages in version A than version B, and so you know, again, they're not really that far off based upon the two numbers they calculated, and so therefore, I mean, less than a page, so they're saying, hey, they're about equally as easy to read. Okay? All right, moving on to part 3 then. And on part 3, take a look at what we have here. We're going to talk about conclusions that you can make by looking at the data sets. Now, one of the key things here is, if you have no strays, okay, so a stray is also known as an outlier, right? And a perfect example of this really is in our classroom. If I were in the classroom and we said, hey, let's take every kid in that classroom and Mr. Miller and let's get their weights. Let's weigh them and plot them on this dot point. Well, obviously, you know, you guys weigh anywhere from, I don't know, 80, some of you guys weigh 100 pounds, some of you guys maybe weigh 150 pounds. And here I am, clear over here on, I weigh about 240 pounds. So if I take myself and you guys, I'm the outlier because I'm way away from all other data points. So you can see here in their example, all these data points are relatively close to each other, which would be a little bit similar to us taking the weights of just the students. Over here, you can see the weights of the students would be, again, pretty close together, and then this would probably represent somebody like me because I'm away from the rest of the data. And so they call that a stray or an outlier. Now, why do we bring this up? Because when we're talking about points of center, if you have an outlier, you want to use the median. Okay, so if you have an outlier like this guy or like my weight, then your best bet is to use the median. If you don't have any stray values, then your best bet is actually to use the mean. All right? All right, so keep that in mind, if you will. I think that's going to be, you know, as you move through some stats classes at the high school level, that's going to be an important feature here. So let's take a look at our example from, oh, I hate these. Let's see if I can skip through that. There we go. Let's go to this one. I have a book publisher testing 2 versions of a new book. Random sample is given 30 minutes to read. What might the publisher conclude about the book versions? All right. So you can see here that they already did the math for you. The median of this one is 25. The median of this one is 23. The mean of this one is 24.4. The mean of this one is 23.7. And so what would you gather here? Well, if you look at this, you might potentially say, hey, these 2 dudes here are outliers or strays. Okay? And so therefore, they may completely not use that data in order to calculate numbers. Whereas in this situation, again, you could probably, because these are only 1 apart, you could say that there really aren't any strays in that situation. Again, let's take a look at what they're saying about this. They are saying those are possible strays. Now again, this is where we have a little difference of opinion potentially when it comes to different math series. You know, I don't know how you could call this a stray if 25 is not a stray. So this is the part that I would question a little bit. This one's obvious, all right? This one's obvious that we have stray data right there. And so if you have stray data, then what's going to happen? It's going to throw off your mean, okay? It's going to throw off your mean. It's not really going to throw off your median too much, okay? So that's why when you have strays, you're going to want to use median in order to compare the answers. And so there's basically what they say about that. Moving on to my next question, you can make a comparative inference about the population using the measures of center. And so they say that about that. So since the measure of center depends on whether stray values should be included or ignored, the measures of center allow for different interpretations of the data. Snapshot of the number of pages read could indicate how interesting the book is. That's something we didn't take into account. How easy the font is, we talked about that. Distraction of the reader's environment. So a lot of different inferences that you could make here. All right, real quickly, let's make sure that part 3, I felt a little like maybe we didn't get some concrete evidence there. So much like we did on 15.2, let's go back And let's take a look at questions 5, maybe and 6 here. And again, in essence, what I'm doing here is I'm doing these with you, for you, what have you. And I want to make sure that we're okay here. So here's question 5. A study is done comparing fuel efficiency of cars. First group generally gets about 40. Second group gets about 40. Based on the mean value of each group, what's the inference? Well, obviously, if they both get the same mileage per gallon, then we would say that they are basically equally fuel efficient. Okay? And then we move on to the next part, which of the following is another conclusion that a person might make from those mean values? Well, obviously, if they get similar gas mileage, that means they're probably similar in size. Okay? Moving on to question 6. Looking for a new house, comparing homes in towns. Median price of town 1 is 450 grand. Town 2, median home price is 450 grand. Again, what are we assuming based upon this? That they are similar in price, and that means that they are likely about the same size. Now, again, we got two problems there that were very similar to each other. So let's see if we can get one that has a little different look to it, and here we go. We have one here where town 1 is 450 grand and town 2 is 507, a little over $507,000. So what would we infer here? We would say, the homes from town 2 appear to be maybe more expensive, okay? Again, one could make a lot of arguments here. One could say, well, maybe it's a better neighborhood. One could say, well, maybe it's a bigger house. So there's a lot of different inferences that you could make. In this particular situation, they would say the homes in town 2 would be represented by a bigger house. Okay? All right, we'll close the door then on 5:15:3. Hopefully everything goes well. Again, if you are having any issues whatsoever with these questions, please feel free to email me as you do it or after you get done or while you're doing it. So, all right, have a great day, everybody.